So Becca, it was like letter C? Is that the one?
It was like, yeah.
Because did you use that equation? Do you have the decimal in the right spot on your equation? 0.0?
Here, probably.
0.16.
Okay.
Oh, which would be great.
Yeah.
Okay.
August.
Oops. So we were just talking about that because Miss Cat, and so Cat was doing that to us.
That's you.
But then I said that you do that to Cash.
Cash likes it just as much as
Miss Miller.
What? How'd you hear it?
Do it. Say it.
What time do we get out of this class?
So Becca, did you get any part of A right?
No,
Or
I
H
was trying to
right?
look at the board. Oh my gosh, it's in like
I got 8A, but like not the rest. And I don't know it.
Wait,
So you guys were okay with this equation, right? The one thing I had Becca quickly check is, was it the decimal point in the rate? But it looked like her rate was good. So then it says, compute the predicted population. Oh, maybe this is it. For the year 2000, based on the formula. For the year 2000, 1970 is our starting year. So 1970 to 2000, you don't use 2000 for the year, you're going to use like the difference between that. So you're going to use 30. Is that what you did? No.
Yeah.
So the T, I believe, should be 30 for that first one when you go to put that in. And then like when you do like, oh no, sorry, that should be 1790, not 1970. Even older than that, sorry. So 1790, whoops, to 2000. So what is that? 210 years? Yeah.
Yeah.
So T is 210 years for that first one. That's letter B. And then C, they're asking you to substitute in a bunch. Yeah, so if you had the years wrong, that would make sense. So like 1850, you know, do the math. So I believe that's 60 years, so that's probably it, right?
Yes.
Yes. The years are always a tough one. They use that in a table, and then in a formula like this, it's very rare that you'd ever actually put the year in, just because years are kind of a year. Like, yeah.
What was our answer for
8B.
I mean, 8C.
I have these three. I'm gonna check. So, like, no, you're still not getting it? So you got the 100 and you got that one. So that's 8B. You got that.
Okay.
I think you're probably okay. And then for the next one, it should be like 60 years. So you put 60 in. So yeah, just watching on years. When they give you a starting point, you're counting the years since then. So you have to do a little bit of math to figure out the T value. We did one like that in our our notes, but I probably didn't make that clear enough to watch out for the years there. Yeah.
Can you go back to that answer?
Yes. Let me pop that up. These were the answers.
For 8C, is it supposed to be 1790 or 19?
So probably 1790. That was me trying to use a normal year versus like really long time ago. Sorry. Yes, it should probably be 1790. Probably makes more sense. And in number 9, I think I saw a bunch of you guys cross on true versus false. It asked if the one graph was bigger than the other, and it's just the idea that the graph is higher. Like, I mean, so is it greater? Yep, because it's further up the graph. So I saw a few people cross that out and should have been false or true. So we're going to talk about logarithms today. We're going to start on that. I probably have more than we're going to get done. I don't know, or The book kind of assumes that you've seen logarithms before, and we do not get it into Algebra 2. Like Mr. Hadfield, and I discussed about it not making it in there, and that's okay, but that means we have to talk about it now.
Do we go walk outside with them?
No. We do not have enough time today. That's one thing about like these skinny classes versus block. I never did like activities with my students when I taught in skinnies, because it was like, you just didn't have time for anything, versus the block, we have time to do whiteboards, or we have time to do Kahoots, and I feel like it was like all business when we used to do short classes like those. We used to have 8 classes in a day.
Yeah, I
We did 7.
7? Yeah. A lot of schools I think do 7. I'm trying to think of where it is. Somebody does 9, and I'm like, oh my gosh, I don't even know how you fit all that into a day.
9's a lot.
9's a lot.
She gave it to me. She didn't do it.
Hardly do 4.
Okay, so let me pull this up for you guys.
She didn't do it. She handed them in her job.
You can take a minute to look at the warm-up questions. Those are asking you to do some exponent rules again.
Well, then they were
So we want to rewrite these first couple using roots, and then I want you to simplify if you're able to, and then down here you can just simplify. You don't have to do roots with these first couple here. And if you don't remember, we'll talk about it. That's, you know. And some of you guys, this has almost been, it's like probably 10 months since you've seen the exponents with the fractions. I know those of you guys like went algebra second half of last year, seen it more recently, but. Do you guys remember what those fractional exponents do? Yeah, it's a root. It becomes a root. So like x to the 1/4 power is really the 4th root of x. And if you forgot about that, that's okay. That's why we review it. So then what would 25 to the 1/2 power be?
2.
So 2 root 25. Does anyone know what that would be? Yeah, the square root and the little 2 root is the same thing. So you're just really taking the square root of 25. So this one's just 5. And if you doubt me, you could just put that in your calculator. Your calculator would tell you that's 5. We're just up here making stuff up for you. All right, the next few are hopefully some exponent rules you remember a little bit better. So like letter C, can I simplify that? What's that going to be? So what's it?
Third.
7. There's 4 and 3, so there'd be 7 total. So if you guys recall, we added the exponents there. Whereas in letter D, what do we do with the exponents? Subtract them, so it'd be m to the 3rd. And if we had to put it in a fraction, we'd have it on top. But since they kind of cancel off the bottom, you don't have to worry about that. And then do you remember negative exponents? What do you think, Tara?
You put it on the bottom, so it's just like 1 over y squared.
Yeah, so negative exponents, they switch their position in the fraction. And all of these things have like a little bit of a connection to what we're doing with logarithms. Logarithms are really very closely connected with exponential functions. So these two, as much as it seems like we're like coming out of left field, like, oh, we're just doing exponents and now we're doing logarithms, they're really kind of one and the same. And I'll show you guys how that works. So a logarithm, and you have a button in your calculator that says log, like it's a thing, it's a function. And the way we write this is like a little, we call this a subscript, so it's down a little bit. So that B is, that's supposed to be a B. My B's and sixes with a lot of like. So that's supposed to be a B and it's called a subscript. Below the rest of the line. And so we read this as logarithm of x with base b. So kind of all of these should be on the same line and then the b should be a little bit below. So the x and the y are all the same size. But so we're saying log of x base b is y. Now that looks like a bunch of gibberish right now. But technically, we kind of know what that is if I put it in exponential form. So you hear base b. So b is our base if I write it in exponential form. So there we're going to write a b. That hopefully doesn't look like a 6. The exponent would be y, and that would equal x. So I can rearrange this into a form, kind of like if you're learning Spanish for the first time and you want to translate something back to English. This is like translating it back to the form we're used to. So I'll show you with these like examples here. So if we write this in exponential form, I take the little base b, it becomes my big B and my exponent. So this little 3 becomes the big value. What it equals becomes our exponent, so that's to the 5th power. And that should equal what we're taking the log of, so 243. So if I did this right, which I think I did, is that 3 to the 5th power should be 243? Yeah. Okay, so at least I didn't just make up numbers there. Now, some of your calculators may allow you to like put this in. Like it might allow you to do log base 3 of 243 if you want to try and see. Like this is going to be helpful eventually, but I'll teach you other ways if your calculator does that. If you type log, it probably has like a little box for you to like go like a subscript. So if you do, where are logs? Probably in the math menu. Oh no, you have it there. Oh, I don't see, let me see. I thought yours did it, maybe not. Maybe not. I have to try and, I'll find it somehow. Don't worry about it today. There is a log button, but the log button isn't this one. It's not log base 3, and I'll talk about what your log is that you guys see in your calculator. And like I said, I think that most of you guys, your calculator can put that in, but at this point we won't worry about it. Now, we could also have to rewrite in exponential form even if it's like a variable. So the base is now m, to the 3rd power would be 2.5. So just getting comfortable with writing this from log to exponential form, just so you can kind of see how to translate that. Again, just getting used to looking at a different language. So this is going to be part of your homework, is just be able to make this translation. You're okay, can I flip? Yeah. So the next one wants us to go the other way, is it wants it down to write it as a logarithm. And again, that's just getting used to like, doing the translation. So log. Now the base is still the base in logs and in exponents. So the 6 is my base. So log of 6, base 6, of, what's going to go next? Look at our rule up above. What am I going to write next? Yeah, Sawyer? The 216. And that's going to equal 3. So just getting used to making that conversion. You could go either way with this. You convert back and forth. So see if you guys can write the next one. So the 17 to the 2nd power equals g. And there's not a lot we're doing with this right now. Right now I'm just like, it's like first day, you learn how to say your name. We're learning how to say our name with logarithms here, so just basics. So log, what's our base? What's the little one? 17. Log of what? g is going to equal 2. Now you might be like, I don't know why you changed it from that. That's very straightforward, very good. I agree. Like that's, but just knowing that we can kind of convert back and forth, this doesn't have a lot of rhyme and reason right now other than just getting used to seeing it other ways. There's a couple of special logarithms, and they're called the common and natural logarithm, just that they are kind of the standard, kind of like square root. So like square root, we know it's the same as this, right? Like that's one and the same, or if you didn't know that, it is. It's one and the same. Those two are interchangeable. Log of x, if they don't write a little base there, we assume it's a log base 10. So if you guys see just log of x like your calculator, is your calculator basically has log base 10 built into it. So if there's no base written in our logarithm, we assume it's a 10. So just to keep it shorter, we assume 10 here. So if it's not written, you can write it if you want, but if if we're talking about just log of a number, we assume it's a base 10. And that's because 10 to some power is something we use quite a bit. That's used in like scientific notation, that 10 as a base is something that's really applicable in a lot of areas. The natural logarithm, we've kind of gotten a little bit more insight with this recently, we've been using this more often, is base e. So, kind of been talking to you guys a little bit about that value e, like with our like the exponential growth. That base e is called our natural logarithm, is the base. So we don't have to write that little e, and there is a ln button, so that should be ln, like a lowercase l and n, and that's log base e. Those two are very common, and those are what's already defaulted in your calculator. So if you have a scientific calculator, you have log and ln. It's like, they're kind of like an important spot in your calculator because they're used, they're frequently used. So just knowing that, it's kind of trying to get you guys used to that. So looking at log of x equals 3, we can rewrite this using the exponential form. So what's our base here? Base is what? 10. To what power? The third. And that's going to equal our x. Hi. What's up? Oh, you want to know what's my new e? 34. It's wrong. She sent a new one, so now she added 14 minutes on to AR1.
It says 177.
Or like, yeah, 3 here, 3 there, like, I don't know. So we can rewrite this as this form. So actually guys, just because you might want to use this in your calculator, 10 to the third power is 10 times 10 times 10, right? So that is 1,000. So check log of 1,000 in your calculator. You can actually use it. What do you get? 3. Look at that. So log of 1,000 would be 3 because 10 to the third power is 3. Or 10 to the third power is 1,000. Okay? And again, I know this feels like we're learning a new language because we are. Like, that's really what's, it's tough. All right, this next one, what's our base in this case? What's our base for ln of 5? What we just say? Base what? No, our base, the little one. E. It should be e. Very good. No, it's a. E, and then the exponent in this case would be y, is going to equal 5. So this maybe is starting to get into a little bit of why we need to be able to do this and be able to rewrite this. So if I'm trying to solve a problem like this, e to some power equals 5. Without guessing and checking, there was no way to do that unless I have a logarithm. So if I want to know what this exponent should be, I can take ln of 5 and it would tell me what the exponent's supposed to be. So kind of trying to see that there's a connection here as to why we're trying to write things in this other way, that going back and forth, when I'm trying to solve for an exponent, these logarithms come in handy. So what we're going to do on the back side here is we're going to do a bunch of simplifying with logarithms and trying to, or evaluating logarithms, trying to do this without using too much of our calculators. Now eventually you'll learn how to put this in your calculator, but I want you guys to be comfortable with what's going on here. So what I would suggest is visually this is hard for me to like read right now. So I'll show you guys what I'm going to do. And you'll get better at this where you're not going to need to do this. But I'm going to say this equals x right now. I'm going to write it in the form we're used to. Eventually you won't need to do this, but for now we will. So my base is 5. What's my exponent? X. That equals 25. So what is log base 5 of 25? It's 2. So log base 5 of 25 is 2. So we're able to do that, but before today, if I had said find log base 5 of 25, you would have been like, yikes, what are you asking me to do, lady? But now when I kind of say it this way and putting it in a language we're used to, it's not so bad. Well, this next one's a little bit tricky, but that's kind of why we did the warm-up question we did. So again, if the x helps you visualize what's going on, it suggests that. And if it helps you to switch, you can. If it doesn't, feel free to leave it in this form, but. All right, so what needs to happen with that exponent? Think about our warm-up question. How does a 5 become something as a fraction? If it's negative, right? If the exponent is negative, doesn't that move it to the bottom of the fraction? So if that exponent becomes negative, it moves to the bottom of the fraction. Does anyone know the relationship between 5 and 125? 5 to what power? The third power. So if I do 5 to the third, it's 125. But how would I put it on the bottom? A negative 3. So our x should be a negative 3 because 5 to the negative 3 power gives me 1 over 5 to the fifth, or 1 over 5 to the third, and then that's at 1 over 25. So this takes a little bit of thinking and like kind of switching between these methods and ideas, but hopefully it won't take, it's like this evaluated would be negative 3. And like I said, eventually you'll be able to put that in your calculator, but I don't want you to kind of like if I gave you a calculator before I taught you how to add, you would never, you wouldn't take the time to learn how to do that thing. So we want to learn how to do it without the calculator, and then we will end up using it. All right, see if you guys can figure out this next one. So log base 25 of 5. And again, our warm-up question might help with this. So 25 to the x power equals 5. What do I want to do with my 25? You don't even have to say it as an exponent. How do I go from 25 to 5? Divided by 5. I can't really do that with an exponent. That's one way to do it. There's something else I can. What's that? Square root is what I was looking for. Square root is the one we want to do. We want to take the square root of 25. But in our warm-up question, I reminded you guys square root is the same as a fractional exponent. So remembering that the square root of 25 is the same thing as 25 to the 1/2 power. So this instance, our x is just a half. All right, see if you guys can try the next row. So see if you guys can figure out this next row. Trying to evaluate this without, me jumping in too much here. And if you get stuck on the first one, try the next one. They're all different, so. the base, when I don't write a base, what's the base gonna be? 10. So don't forget here, even though we didn't write it, this one's base 10. And again, I'm trying to find what these all equal. So if it helps to put an X there, do that. So if I don't write the base, we assume it's a 10. So I'm going to write these in exponential form instead, if that helps. Someone's alarm going off. It sounds like Miss Miller. She's left her alarm again. Okay. So again, we're looking for like what the exponent would be in all these cases. So what power do we need in log base 10 of 100? What's that power going to be? It's just going to be 2. So this is just going to equal 2. You want to write it as x is 2. You want to write it equals 2. It's just kind of understanding that relationship there. How about letter E? Did you guys figure that one out? Yeah. 3. 4 to the third power is 64. If you're not comfortable with your exponents, feel free to grab a calculator. I mean, I'd probably double check that one, especially if I was like, you know, in the middle of a test or something like that. So that one should just be 3, because 4 to the third power is 64. So you want to figure out letter F. What would make that to be 1? Yeah. 0. Anything to the 0 power equals 1. So log base 7 of 1 should be 0. Like if you check log of 1 in your calculator, it should be 0. Because anything to the 0 power is 1. All right. Now these ones I threw some exponents in, so it makes it a little bit trickier. But once I write it this way, I think it'll be helpful. So 5 is the base. It's being raised to the x power. And that should equal what we're taking the log of. If I write it that way, is it pretty obvious what x has to be? Yeah, that's all it is there. So x would have to be 4. The next one is getting us into some of the properties of logarithms that we're going to start noticing. Maybe this one did as well. Is that log base, that's to see a 9 of 9. It's kind of like a G, sorry. Well, even if it was a G or another letter. So it's saying 9 to the x power equals 9. What does x have to be? 1. So that if we have like the same base and we're taking the log of that, it's going to end up being 1. So kind of one of the rules we're going to get into next week is some of those rules that, like if those match, those kind of cancel out. Similarly with letter I here, this is base 10. So I have 10 to the x, or sorry. I'm going to do y in this case, just because they already have an x here. Kind of freaking me out a little bit, this x, I don't want to pick a new x and be confusing that way. So 10 to the y power equals what we're taking the log of. What does the function need to equal? What does the y need to equal? X plus 2. So this is just going to be x plus 2. So what I'm kind of getting at is like those kind of cancel out, and we're just kind of left with the exponents. So we're going to talk about that next time. And I know this is strange for some of you guys, and then others of you, I think, just pick up patterns and languages a little more quickly. I kind of a lot of times talk about math being like another language. I was good at learning Spanish, the memorizing part of it, because of the fact that I'm good with like those types of patterns. This is kind of similar patterns in this case. I want to point out one thing about a property of logarithms. Now this is supposed to be n's being raised, so my font didn't work very well. So n to the log base n of x. So I'm taking the n and I'm raising it to a power that happens to be a logarithm. Now when that happens, if those bases are the same, these are both n's, these cancel, and this will just equal x. So if I'm taking a base, raising it to a log power with the same base, those will cancel. And we'll see that down here in a second. So in this case, it's 10 to the log base 10 of x. So again, they just cancel, so this is just x. This is e to the log base e of x. Those just cancel. So if the log base and the exponent, or the base of the function matches the base of the logarithm, they will cancel. So like number 4, the 8 and the 8 cancel, so what are we left with? M. So you're just left with M in this case. And these are supposed to be that easy. Now, obviously, they'll be in bigger problems later on, not today, but just getting used to them. This is also base E, so those cancel. So this is just 7. And they can be variables as well, and then it's just 4. Okay? So, what I'm going to give you guys is a worksheet that's going to take you guys through these types of problems, just this practice. And there's a lot of them because of the fact that I think it's good for us to practice the different types.
This is down here.
Yeah.
Right over that.
Yeah. So the only thing is, I would say that number 34 is probably a little too early on in what we're doing right now, so if you want to skip the last one, I think the rest of them you guys should be able to do and kind of do the conversions between them. Okay, so I'll give you guys the rest of the time to get working on this. It's a little on the long side, but I want you guys to practice lots of problems like it just so that you get comfortable. And use your notes to help you. I think we kind of did an example of kind of each type that comes up with. So again, 34 you can skip or wait on. We'll talk about that one next